Hello there, my name's Mr. Evangelista, and welcome to another episode of Evangelista Science. We did 8.1 last time, so we're going to do, you guessed it, 8.2 this time. Talking about the properties of acids and bases. Let's start off with bases. So the bases that we are going to see, there are going to be 4 of them. We've got hydroxides. That's going to be pretty much a metal with an OH at the end. Those are hydroxides. We're going to see metal oxides. These are metals with an O at the end. We're going to see carbonates. That's CO3. So here's sodium carbonate, potassium carbonate. And we're going to see hydrogen carbonates. That's HCO3. So sodium hydrogen carbonate, potassium hydrogen carbonate. And all of these will dissolve in water to form OH. That's why they're going to be bases. So here's ammonia plus water. Ammonia is a base, so it's going to accept the hydrogen from water. So it's going to form ammonium and hydroxide. Acids. Acids are going to react the following ways. Remember that a salt is a metal and a non-metal. So if I get an acid and a metal, then I get a salt plus hydrogen. This is how we made the hydrogen gas in our little little rocket experiment. We put zinc in hydrochloric acid, and that made some hydrogen gas for us. Now, if you get an acid and a base, you get salt and water. This is one of the neutralization reactions, and it is exothermic. Lastly, you can put acid with a carbonate or a hydrogen carbonate, and that will make salt plus water plus carbon dioxide. Now, just real quick, these are the ions from chapter 4. Hopefully you remember them, because when we're talking about salts, salts are metals and a non-metal. The non-metal could be one of these polyatomics. So we have hydroxide, nitrate, hydrogen carbonate, carbonate, sulfate, and the phosphate, and ammonium. Okay, let's do some practice. So, see if you can go ahead and complete these equations. I'd ask you to pause the video and try, and then I'm going to go over the answer. So, here we go. Here we have a acid and a metal, and so that's going to make a salt plus hydrogen. Okay, acid and a metal, we get salt, so we have the metal zinc and the non-metal chlorine, plus hydrogen. Notice, always pay attention to the charges. Chlorine is -1, zinc is +2, so when we do the crisscross rule, our formula is ZnCl2. The next one is an acid and a base, so this is a neutralization reaction. We should get a salt plus water, and indeed we do. The salt is the metal sodium and the non-metal chlorine. Sodium is +1, chlorine is -1, so 1 and 1. Plus water. The next one, we have an acid and a carbonate. So we're going to get 3 things. We're going to get a salt, we're going to get water, and we're going to get carbon dioxide gas. Notice here our salt looks a little tricky, but it's just the metal, sodium, and then the non-metal is this polyatomic ion sulfate. Now sulfate has a charge of -2, and sodium has a charge of +1. That's why there are 2 sodiums and only 1 sulfate group. In this one, we have an acid plus a hydrogen carbonate, so a base. And so we are going to get 3 things. This is going to be potassium methanoate, water, and carbon dioxide. CH3COO. I'm not sure if this is one of the polyatomics you should know. I'll let you know in class. But this is the non-metal and potassium is the metal. Lastly, we have a copper oxide plus H2SO4. Copper oxide is a base, and this is an acid. So acid and a base, we get a neutralization reaction. It should give us a salt plus water. Let's do a little more practice. Make the following salts with an acid and a base. If I'm trying to make sodium chloride, what acid and what base would I use? Quick little note from the IB. The only carbonates and hydrogen carbonates that you can use are ammonium carbonate, sodium carbonate, potassium carbonate, sodium hydrogen carbonate, potassium hydrogen carbonate, and calcium hydrogen carbonate. The only hydroxides you can use are ammonium hydroxide, lithium hydroxide, sodium hydroxide, and potassium hydroxide. Okay, so I'm trying to make sodium chloride. So let's start with the acid. If I want to have a chloride, I should probably use HCl, hydrogen chloride, right? Hydrochloric acid. And if I want sodium, well, I can just use this hydroxide, sodium hydroxide. And so I get HCl plus NaOH. That's an acid and a base. It's a neutralization reaction. And so I get the salt NaCl plus water. Copper nitrate. So let's start with the acid. I want to get a nitrate, so I should probably use nitric acid, HNO3. Now copper, I don't see the copper metal in any of these. So I'm going to have to use the copper oxide as my base, since I can't use a carbonate, a hydrogen carbonate, or a hydroxide. And so again, this is a neutralization reaction. We have an acid and a base. I have nitric acid plus copper oxide. And here's my salt, copper nitrate, plus water. Last thing we're going to talk about is indicators. We've seen indicators in class with the water to wine demo, as well as the bromoethyl blue with acid breath. They change color when they're in acids or in basic solutions. And so this is a titration setup. You pretty much put an indicator in this beaker, and you either put an acid or a base in there. And you pretty much what you do is at first that color of that indicator is going to be alkali, and then you're going to add acid until the alkali color disappears and you get this more neutral color. After you've added that much acid, you can see, oh, I added this much acid, then they can tell you the concentration of how much base was in that beaker there.